how you can avoid problems by keeping your drip lines clean. Hello, I'm Emma Groen, your cultivation support companion from Biota Nutri. Today we'll be looking at common issues in your fertigation system when using organic fertilizer. We'll show you how to avoid drip line contamination with cleaning and regular maintenance with an overview of each method. I'll also provide you with a way to get a free technical document with much more detail and instructions on drip line cleaning methods. Let's go ahead and look at the common issues and solutions. Common drip line problems usually come from contamination in the system, which causes blocking of the drip heads and other issues. To demonstrate this, let's look at an example of a nutrient solution with a pH of 5. As you can see, fungi has developed over time. This fungi will continue to grow if no steps are taken. Now let's look at examples of the same solution where we have added peroxide. As you can see, the difference is no fungi growth when the peroxide is present. There are 3 methods to maintaining your drip lines. The first is flushing, the second is using chlorine or hydrogen peroxide injection, oxidation, and the third is by acid injection. It is important to flush the system in the order that the water flows. You need to flush all lines for at least 2 minutes or until the water runs clean. Step 1. Flush the main line, while submain and lateral flush valves are closed. Step 2. Close the main line flush valve and start flushing the submains. Next, close the submains flush valve and flush the drip laterals patch by patch. Often, 2 slugs of sediment are observed from laterals, the first being material accumulated at the end of the lateral, and the other being newly disturbed material along the length of the lateral. Step 3. Close the laterals in consecutive order and check that all drippers are working. A minimum flow velocity of 0.5 meters per second is generally recommended for flushing lateral lines. Most sediment will fall in the end of the dripper tubes, where water travels relatively slowly, so it's important to flush with a sequence that is suitable for your design. Use this chart to calculate what your system needs and to determine if you have the correct velocity. You can measure the flow rate from the end of a lateral into a bucket. If you would like more detailed information, just request the Maintaining a Drip Irrigation Technical document by emailing info@biota.nu. Oxidation can be used to reduce blockages caused by organic matter. Chemicals such as chlorine and hydrogen peroxide are oxidizing agents that can kill bacteria, algae, and other organic matter in your system. Let's start with chlorine. Common chlorine compounds are sodium hypochlorite, which is a liquid, and solid calcium hypochlorite. Sodium hypochlorite is easier to use and relatively safe compared to calcium hypochlorite. There are 2 main chlorine application methods. The first and most common is intermittent treatment, used to prevent or correct organic matter building up in the system. You'll want to inject between 10 and 15 milligrams per liter between 1 and 4 times during the season, ensuring that 0.5 to 2 milligrams per liter of free chlorine is detectable at the end of the lateral furthest from the pump. You can use a readily available swimming pool test kit to detect free chlorine. First, flush the system in the correct order, and then inject chlorine until it reaches the last dripper, usually 30 to 45 minutes. Next, run the pump for a further 10 to 15 minutes, and then shut the system down for between 2 to 24 hours, or let the chlorine sit overnight. After chlorination, flush the system again. You should also consider carrying out a systems test at this stage to determine if the procedure is improved system performance. Continuous treatment involves injecting chlorine during every irrigation and should only be used if extreme algae or bacterial problems exist. Usually 5 to 10 milligrams per liter is injected and adjusted so that 1 milligram per liter of free chlorine is detectable at the end of the system. Please note, concentrations above 2 milligrams per liter can result in phytotoxicity or leaf burn in some annual crops. Unlike chlorine, hydrogen peroxide is effective if irrigation water has high pH levels and is often preferred by organic farmers. Biota recommends using hydrogen peroxide, but it is more corrosive than chlorine, and therefore safety procedures must be followed. A similar method of calculating chlorine injection rates is used. Hydrogen peroxide is available in a range of concentrations, with 35% or 50% generally recommended. Between 30 to 50 milligrams per liter is injected, and then using test strips to detect a desired 8 to 10 milligram per liter at the end of the system. Finally, let's look at acid injection. While chlorine is used to manage organic deposits in drip systems, acids can be injected to control mineral deposits. Dissolved impurities such as calcium and iron in the irrigation water can precipitate out in the drip system. If this problem has occurred, precipitated calcium salts can appear as a white film on the inner surface of the system. You might wish to cut open a number of emitters for visual inspection. These impurities can often be dissolved by lowering the pH of the water, usually by injecting dilute solutions of acid, such as hydrochloric, sulfuric, citric, or phosphoric acid. Phosphoric acid has the added benefit of adding phosphorus to the soil. Please note that acid should not be used if asbestos cement pipes are part of the irrigation system, as it will attack the pipe wall and release fibers, leading to mass blockages. Acid and chlorine injection requires skill and the following of safety procedures. You may want to hire a contractor to undertake these types of maintenance at your facility. So today we've covered the main ways to maintain your irrigation system when using organic fertilizers. If you would like more detailed information, just request the Maintaining a Drip Irrigation Technical document by emailing info@biota.nu. And don't forget to subscribe and follow us on social media for more content about growing with organic fertilizers. I'm Emma, and until next time, goodbye for now.